Imagine a world so dangerous, so unstable, and so violently hostile that its very existence challenges the rules that shape stars, planets, and gravity itself. Today, we travel to the most dangerous planet ever found. A world that should not exist. A world that scientists struggle to explain. A world that bends the limits of physics each time its orbit completes another impossible loop around its star. Prepare yourself to enter a place where fire moves like liquid metal, where winds roar faster than sound, and where the surface reshapes itself under forces so extreme that they seem borrowed from nightmares rather than nature. The universe is wide and full of strange worlds, but this planet stands apart from all others. It is not simply extreme. It is not simply unusual. It is a direct insult to everything planetary science claims to understand. A planet like this should have been torn apart long before it fully formed. It should have been swallowed by its star, ripped into fragments by tidal forces, or shattered by its own internal pressure. Yet Erit is orbiting quietly, defiantly, as if unaware that it violates the limits of what physics allows. As telescopes observed it for the first time, researchers were struck by the same unsettling realization. This world is not supposed to be here, and if it exists, then our models of how planets form and survive may be missing something enormous. To understand its danger, imagine standing on a surface where the ground beneath your feet is not solid rock, but scorched mineral melting into glowing streams. The surface temperature climbs high enough to vaporize iron, melt stone, and bake the atmosphere into metallic clouds. These clouds, heated beyond comprehension, form droplets that rain back to the surface, not as water, but as liquid metal. Imagine the sound of that metallic rain hitting a landscape already glowing with heat. Now imagine that these storms do not come from weather patterns we understand, but from violent gravitational pulses that tear through the atmosphere every time the planet approaches its star. On T's world, weather is not weather. Weather is destruction. As the planet orbits, it is stretched and compressed like a piece of soft clay. Gravity twists it, bends it, pulls it apart, and slams it back together. The planet should crack into pieces, yet somehow it remains whole. These tidal forces generate heat far beyond anything caused by sunlight alone. They churn the interior of the planet into a boiling ocean of molten rock. This internal ocean shifts under the crust, reshaping mountains, breaking continents, and releasing plumes of vapor that burst upward like fountains of flame. Nothing could live here. Nothing could survive even a moment here. And yet this planet glows with a fierce beauty, a silent reminder that the universe does not care about our expectations or our limits. Telescopes reveal another terrifying detail. The planet's orbit is impossibly close to its star, so close that the difference between the star's gravity and the planet's own is barely enough to keep it intact. A slightly different orbit, even by a fraction, would tear the planet into spiraling fragments. The star's radiation blasts it constantly, stripping away atoms and turning its outer layers into a blistering haze. Under such circumstances, its atmosphere should have been lost long ago, evaporated into space. But somehow a thin, stubborn shroud of gases clings tightly to its surface. Scientists still debate how this is possible. Some propose magnetic fields. Others suspect unknown chemical cycles. None of the simulations match what we see. The planet simply refuses to behave. Even stranger, the side facing the star is so bright that it glows like a furnace, while the far side sinks into darkness cold enough to freeze gas into crystals. Between these extremes lies a twilight zone where winds blow at unimaginable speeds. These winds howl around the planet, dragging vaporized minerals from the day side into the night side, where they condense into exotic materials that cannot exist anywhere else. Then the winds return, carrying those frozen crystals back into the burning side where they melt instantly. The planet cycles its own minerals endlessly, as if sculpting itself over and over in a loop of destruction and rebirth. What puzzles scientists most is that ordinary physics predicts that such a planet should spiral inward. Planets this close to their stars gradually lose momentum and fall into the star like pebbles, sliding down a drain. Yet this world's orbit remains strangely stable. It does not fall. It does not decay. It simply stays as if locked in place by a mechanism we do not understand. Some researchers believe an unseen companion planet may be compensating for the orbital decay. Others propose a resonance effect between the planet's rotation and the star's gravitational cycles. But no definitive answer has emerged. It is a cosmic riddle orbiting in plain sight. The danger of this world is not limited to heat or gravity. Deep within its interior, pressure rises so intensely that materials behave in ways unknown to science. At these pressures, molecules reorganize themselves. Atoms shift into exotic states. Some theoretical models suggest that the core of this planet may contain forms of matter rarely seen outside extreme laboratory conditions or neutron stars. If true, this would make the planet one of the most exotic objects ever found. It hints that planet formation may have pathways far stranger than the gentle accumulation of dust and gas we teach in textbooks. The existence of this planet challenges another assumption. Planets are usually destroyed when their stars age and expand into giants. Yet evidence suggests that this world may have survived such violent phases in its star's history. Some researchers speculate that the planet originally orbited farther away and was later dragged inward by complex gravitational interactions. Others propose that the planet formed close to the star in a region where no planet should have been able to exist. Both possibilities imply that our models of planetary evolution are incomplete. When astronomers published the first detailed study of this world, many expected the scientific community to find a simple explanation, but instead, the planet sparked debates that continued to this day. It is too close, too hot, too unstable, and too massive to match any known category. Its atmosphere should not exist. Its orbit should not exist. Its structure should not exist. And yet, it is there, shining defiantly. Each time its glowing surface swings into view, imagine drifting far above this planet. You would see its molten lakes, shimmering like pools of fire. You would watch its metallic clouds swirl, forming spirals of reflective vapor. You would see lightning storms crackle across the dark side, igniting the thin atmosphere with blue and violet flashes. You would witness the entire world trembling slightly as tidal forces pull at it with every orbit. And through it all, you would feel that haunting sense that this place is not simply dangerous. It is ancient and powerful, shaped by forces beyond our understanding. This planet is more than a scientific anomaly. It is a reminder that our universe is creative in ways we cannot yet imagine. It shows us that planets can form under conditions we once believed impossible. It teaches us that our theories must evolve as we discover more. And it invites us to wonder how many other impossible worlds drift through the darkness unseen. As we leave this dangerous world behind, one truth becomes clear. The universe is not a quiet, organized place. It is wild, unpredictable, and full of surprises. Every new planet we discover expands our understanding of what nature is capable of. Some worlds are serene, some are beautiful, and some, like this one, are so extreme that they feel like warnings whispered through cosmic winds. If you enjoyed this journey into the most dangerous planet ever discovered, make sure to subscribe so you can join me for the next exploration. There are countless worlds waiting out there, and some of them may be even more impossible than this one. The universe is full of mysteries, and together we will uncover them one by one.